because I know you want also to relax between the talks or get questions or take your notes. But don't forget that all talks are going to be uploaded, not updated, strange, are going to be added in our YouTube channel. And let's give it up now to Sheeraz, aka PwnMeow. He is a content engineer for Hack the Box. He is a member with us 1.5 years. He has an amazing and inspiring story. I will leave this up to him. So let's give it up to Sheeraz that he will teach us all about Kubernetes. Hello, Sheeraz, how are you? You're muted. Let me.
Oh, hi, Swati. Sorry about that.
No, everything is perfect. How are you, Sheeraz?
I'm good. How about you?
I'm very excited that we started the live stream. Before, I was a little bit, anxious if everything will go well, if we have enough viewers, or if they enjoy them. But it is one of the most successful lives. I'm very happy about it. Thank you guys for your engagement and your feedback, and always feedback because it makes us better. So yes, Shiraz, what about you? How I think you will do your introduction by yourself. But something that I would like to say is that I want to thank you very much because you pulled this amazing presentation and lab almost last minute to create this amazing talk. So thank you very much for your effort. And I will ask you one thing. I don't know if you will say it later. Why Kubernetes?
Kubernetes is one of the best or one of the most popular products right now that is being used for orchestration. There are other competitors in the market, but Google created Kubernetes. It is a little bit complicated to set up, but then it provides a lot of options for deployments. On the other hand, if you see Docker Swarm that is competing with this, it doesn't provide a lot of these features of that granular control that you want when you are trying to deploy an application. That's why Kubernetes.
Okay, perfect. Thank you very much. And we will learn also today about deployment and the setup and features and everything.
Yep, you will.
Oh, nice. So I'm going to end your presentation and I'm going to leave you with the community. So let's give it up to Siraj. I removed him. What the?
Hi everyone. This talk is about Kubernetes fundamentals. So it is Kubernetes 101. This workshop doesn't need for you to know anything about Kubernetes as of now. Everything that we are going to cover in 30 minutes from now would be completely basics. And this point after this workshop, you would have to explore other more advanced stuff about Kubernetes, but you will know the basics. About me, I am Shiraz, aka PwnMeow. I'm also a content engineer at Hack the Box. You might have played some of my boxes. I've worked in security from last 2 years. I have 24 plus CVEs. I also love automation. That's why Kubernetes. And I also blog about all my experiments and Hack the Box write up on sheerazali.com. You can find more about me on Twitter or my website. So let's talk about Kubernetes. What is Kubernetes? So according to Google, this is what it says. Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services. Okay, that's a lot of jargon for someone who doesn't understand Kubernetes. The first time I read it, I couldn't understand it either. In simple words, it is a container orchestrator which helps manage your applications that are running on containers. So it is a manager for all your containers that you're running your applications on. It enables you ease of scaling, and we'll see how it does that. Kubernetes is arguably the most trending technology in cloud computing these days. The more important question is why Kubernetes instead of what Kubernetes. So, so in the earlier days of application development, there used to be something called monolithic applications. There still are monolithic applications. This is one of the architectures how you would code an application. Now, in these type of applications, you have models, you have views, and you have controllers, and this one big giant application does it all. That's why it is called monolithic, just like a one big rock. So it serves the pages, it serves the static content, HTML, CSS, JavaScript. Then it also handles the functions or controls of the application like sign up, login, shop, support. And then it also manages the database schemas and data access and all of that. So a client would come in and it would serve the web page, handle all the functionality. And now there is one problem with this application. So let's say this specific application is an e-commerce application where we as an e-commerce application are doing um, a, a advertisement campaign. So here we have the shop function of the application where we are expecting a lot of users to come in and shop from our website. Until now, we are able to handle, let's say, 1,000 users, but now we are expecting 10,000 users. And for for that kind of traffic, we need a lot more resources than what we have deployed right now. So the problem comes here. If we want to just expand, just give more resources to this shop section of the application, the problem occurs that we have to give it to all of the application, and it would require a lot more resources to serve the whole application as one instead of just the shop application. To solve this problem, there is another architecture which is called microservice architecture. In this, the client would come in. There would be an API gateway for the client. Let's say they want to go to the root of the website, then the API gateway would handle it and send it to the static resource service that is running. It will only serve web pages, and that's the job that it does. We break these down into various smaller services, like this service just does login, this is just the support application, this is just the sign up and registration, and then the last one is the shop. So now if we look at this and look at from the same example we had earlier, where we were trying to host a lot more users. Now, if you just want to give resources to the shop application, we can just give resources to the shop container, and it would be able to handle all most of the loads instead of giving it to the whole application. So that's how how microservice architecture works. Now, one of the things that microservice architecture has is containers. All of these applications are deployed on different containers, which do just one thing, and it does one thing right. Uh, but let's imagine something like Hack the Box, where we have machines, we have Academy, we have multiple different services throughout, uh, and it is divided into separate microservices. Now these microservices are doing their job correctly, but all of these microservices are being developed by different developers. Moving on to tell you how why containers are cool, and we'll understand how that comes into picture here. Containers are cool because first of all, there is a problem called matrix from hell. So all of these microservices are being developed by different developers. They are choosing different libraries, different operating systems, and the developers themselves are working on separate projects, so they are not really talking to each other in this matter. Now the problem is when they try to make the application together or deploy it, there's something called matrix from hell which comes in. So let's say one of the developers was using Arch and the other developer was using Debian. So there are some libraries that are only specific to Arch. Let's say it's a PDF generation library. Now the only one like there are ways around it, but one of the easier ways to do this is either you change the code to include something. Let's say you were deploying on Debian, so you use a Debian library, or you port the library from Arch to Debian, which is a lot more harder to do. Um, that is something when dependencies and these libraries cannot like they create conflicts between each other. That is called the matrix from hell. Um this is what Docker containers or these containers solve. So they would run on the same OS layer of or the hardware, but it will share the Linux kernel. It will share the Linux kernel, and over that kernel, it will deploy the image. Let's say we are spawning a Debian container, then it will have a Debian image on that. So this is how it solves the matrix from hell problem. It is also very resource efficient because if we were to run an application, a whole giant application, it would consume a lot more resources. But a smaller container is easier to spin up and manage. So it is very resource efficient. It also increases portability. So if you don't have problems like it works for me, but it doesn't work for you, a developer can just straight up write a Docker file and then pass it on to the second developer, and it will work for everyone because that's how Docker is created. So it also makes sure that there is consistent operation throughout. So the developers and DevOps team doesn't. So if the DevOps team or the infrastructure team is responsible to deploy stuff, shouldn't have to know how the application is working. They should just manage the infrastructure themselves, and that's where Kubernetes solves that, or container solves that issue, where the application developer has written a Docker file or a Docker image, and the infrastructure would just take that Docker image and deploy it in multiple places instead of knowing all the libraries, installing it in one place, and all of that hassle. So overall, it is better for application development, given that it solves so many problems that is a problem with compatibility on all of that. And this is where, because all of this is running on containers, we need a container orchestrator because managing so many containers is hard. Let's look at Kubernetes as architecture, and then we will move on to how it works. So these are the main components in Kubernetes architecture. Let's understand this. This is a master node. The master node is a virtual machine or a physical host. Uh, Same for worker nodes. Nodes are basically virtual machines on which different type of setups are deployed. The master node itself acts as a brain of the whole cluster, where the Kube API server is a front end, from which, let's say, this kubelet agent would send all the information to the Kube API server, and then it will pass on to these other elements of the master node. These are not exposed to the whole cluster. Only the Kube API server is something that talks or passes on messages. Now, kubelets would send in information. It is passed on to the HCD cluster. HCD cluster is the data store that Kubernetes uses. It is a key value store, which is which implements the logging in Kubernetes. So it will hold all the logs for pods and containers that are running on the worker nodes, what is failing, what is running, what has been deployed, how long ago it was deployed, and all of that. All of those information is stored inside the HCD cluster. The kube scheduler is responsible for putting pods or putting containers on worker nodes. It looks at the resources available on the worker nodes and makes sure whenever it gets an order from kube control manager, then it puts up a pod wherever it sees that there is appropriate space and resources. Kube Control Manager is kind of like the monitor of the whole cluster. It keeps an eye on different pods, let's say we want at least 3 replicas of our application running at each time, then the Kube Control Manager would make sure that at all times there are 3 of these running. If one of this fails, then it would receive the message from the kubelet to the kube API server, and then it will order the kube scheduler to put another pod here. On the worker nodes, there are like 4 components that are necessary to understand. The kubelet acts as an agent. So it is an agent on the worker node which sends in information to the master node. The kube proxy is for the networking of the whole cluster. There is a container runtime environment. And like most commonly, Docker is very popular to use, but there are other container environments as well. And then there are pods, and we'll see what are pods in the upcoming slides. So deploying a Kubernetes cluster is a tedious task, and if you want to try it, you can just follow this article. It is very easy to follow, and just you can do it on your own. But we can't cover that in this small workshop. While I'm going to use Katacoda's Kubernetes playground for my workshop demos. Now let's understand. We saw these are pods. Now let's understand what are pods. So pod is the smallest unit in the Kubernetes cluster that is storing the whole application itself, or a part of the application which is complete. So let's say there is the sign up or the shop part of the application. The complete shop part of the application is is packed up into a container. And then that container is encapsulated inside of this object called pod, uh, which is the smallest object in Kubernetes. This is the smallest object you could make in Kubernetes. This makes it easy for Kubernetes to generally deploy stuff. So let's say that you have two users here and there are two pods. Now let's say there are in our arbitrary world there is one pod that can only handle one user at a time. So let's say there is another user that came in, Kubernetes would automatically deploy another pod and serve that user. Make sure and equally basically divide the load on all three pods. Let's say that all the hardware resources run out of this node, then it will move on to deploying and equally distributing the load to different nodes. Like here we are just now we deployed three pods. Pods generally have one-to-one relationship with the containers, although we can have multiple containers inside each pod. But the containers generally are helper containers, and whenever there is a new instance of an application that needs to be run, a new pod is spun up. The easy way to create pod is, or doing it from the command line, is if you just run the kubectl run command in the name of the pod, and then if you give the image, here I'm using Nginx, it will create the Nginx image or the pod itself. The name of the pod is this, and if you say get pods, then you'll see that the pod is now running in a running state. So Nginx instance is running on the Kubernetes cluster now. If you see it with the dash wide option, we can also see that the IP address of the pod can be seen, but we cannot straight away go to this IP address and visit the Nginx page right here. We'll see how we can do that later on. So let's see. This was an imperative way or the way from the CLI to create a pod. But if we want more control and a more descriptive manner to create a pod, we would use a YAML file or JSON file, but I prefer YAML. So let's understand what are the main aspects of this YAML file that creates a pod. So first is all Kubernetes objects have these four particular properties. So first is APIs version. There are newer APIs of Kubernetes, but the pod is included in the first one. So we are selecting V1. Then there is pod. The kind of object we are trying to make is a pod, and this is case sensitive, so we need to keep the P capital. If we open up the metadata, we have two properties, the name of the pod that we are making and the labels. These labels are for us to group these pods together. These are completely custom. We are using a label for the app itself. So the app that is the pod is running is Nginx. So I use that. And the group of pods it is running in is front end. So that's running here. The last part of the pod's YAML file is that pod specification is that we have specs. The specs have containers that the pod would run, and these containers, there can be more than one container, but right now we are just running one container with the name of the container being Nginx, and the image that it is going to pull from Docker Hub is also Nginx. If we go to our playground, I have these files created already. So if I do kubectl apply dash f for file and then we do pod.yaml, it should create a pod with the name of Nginx. If we now do kubectl get pods, it's creating the container. And once it is created, it will show us that it is running in the running state now. It takes a little while because I guess these are running on, this playground is running on very low on resources. It doesn't take a lot of time generally. So it will show up like this in the running state. So now let's talk about the pods themselves. Just like we had a problem where if we were deploying more than one container, the problem was that we had too many containers to manage them. And in the pods case, it is the same thing. If there are 6 pods to be deployed, we have to deploy each of them individually, which is not solving our problem. That's where replica sets comes in. So let's say that there is your one pod and three users came in, and this pod cannot handle the load for these three users, and the pod crashes. The container in itself crashes. So now the users don't have access. In this case, if we deployed this pod inside of a replica set's function is to always have, like, let's say we specify that we always want two or three of these pods running at all times. Then the replica set's job is to make sure that at all times, if I want two replicas running, then there would be two replicas running. So if this pod dies, the replica set would spin up another pod instantly and give access to that. Now let's look at replica sets as well. If we go to replica sets, we again have these four root properties like in all Kubernetes objects. This is universal. The API version for replica sets is app/v1, just to notice. No, note that. The kind of object we are creating is replica sets, and the metadata is very similar to what we had in pods name. The name of the replica set is Nginx. The labels we are selecting for the replica set are app Nginx, and group frontend. Although the spec section is interesting. So inside the spec section of the replica set, we have the template. The template is nothing but the whole pod.yaml file. So the name of the pod, the labels of the pod, and the images of the pod. So this is exactly the same. Then we are specifying replicas. So we want at all times two replicas to be running in the Kubernetes cluster. And then at last we have selectors. So the selectors where they come in is they basically help us select the pods that are running already. So now let's say that we deployed a pod with these labels already, then replica set would go ahead and include it inside of this replica set. So if there is one of the pod running already, then it will only create one more pod with the label of app nginx. And that's how it does it basically. So if we go ahead and if we now get to the pods, yeah, that works. Now if we do kubectl apply dash f replica sets, this is the same file we saw just now. It created a replica set, and if we now do get pods, we should see two pods. So this one was already running, so it included that already, while this one is being created by the replica set. And if we want some more details on that, there is only one replica set running. The desired number of pods is two. The currently running are two, and two are also ready. So the replica set is basically running and tracking the pods. This is what we saw in the slides as well. Now let's look at deployments. Now replica set solve the problem of having to bring up or managing a lot more containers. But now let's say what if we want some more granular control on the pods themselves? So deployments basically help us manage pods. So it deploys these pods in a replica set, but it also gives us options to, let's say we want to upgrade the version of the application. This was running on version 1, and we just developed a new version. We want to deploy that new version of the application. This can be handled by Kubernetes deployments. They also have something called rolling updates. This is a strategy of Kubernetes updates. We will see in the upcoming slide. They also provide rollbacks. So if we upgraded our application and something went wrong, we can roll back our changes to the previous ones. And we can easily configure resource allocations, image updates, rescaling of the clusters from the deployments very easily. We can also pause and resume any updates that we want to do with our deployments. So this is how it kind of does it. This is called rolling updates. So the rolling updates work in such a way where, let's say, you have users coming to your application. So half of the pods in the cluster would go down and upgrade at the time. So these pods are being upgraded while Kubernetes is sending all the different load and traffic to these pods that are up and running. Once these come back up, then these would go down and get upgraded. This is how kind of deployments work. Now let's look at the deployment configuration file. It is exactly the same as a replica set, but the kind is now deployment. And once you set the kind to deployment, you have the features of rollback and upgrade and different properties such as that. So it deploys a cube. If you get a deployment, it says 0 to 2 is ready. Then initially, if you get the replica sets, it deploys both of these pods, and we have two running in the ready stage. You can also use kubectl get all command, which will give you almost everything that there is running in the cluster. Now, until now, we had deployed pods, we had scaled them up, we have scaled the cluster down, we upgraded things, but we still cannot access our Nginx pod, which is kind of funny. So now let's see how Kubernetes networking works. So this is the node itself. This is the node's IP address. Kubernetes creates an internal network inside of the node where each pod is given their own IPs. So there is an internal network with 10.10.0.0 as the subnet, and then these are the two pods that are running. But the problem occurs when there are more than one node. So if now there is a node with .20 and there is a node with .21, both of them are running a Kubernetes cluster. We want to join them together so that we can share the pods across or share the load across the cluster. But now the problem occurs that they both have a private internal network and there are IP conflicts. That's why Kubernetes does not implements a networking solution in them that like in themselves in itself, but it has third-party solutions. These are few of those solutions where Calico, Cilium, DeepNet, Flannel. These are multiple these solutions, the third-party solutions that handle Kubernetes cluster networking. If you follow the deployment article that I mentioned in the second slide, then you would probably use ViewNet to install a networking solution on the cluster, which unifies all the network and creates a virtual network of all the hosts. Now let's see services. So this is where things get interesting. We want to access our Nginx pod, and so there are these three pods. These two pods are internally connected. So let's say one of them are Redis server and one of them is MySQL server. We don't want to expose those. We just want them to talk to this pod, which is running our Node.js application. And the Node.js pod wants to talk to users, or the user should be able to visit this pod. So in between those, we create a service. The service exposes one of these ports and redirects the traffic and enables intercommunication between these pods. So why there is a need for a service? So let's say until now we saw that from the internet itself, if we curl the IP of the pod, we can't get access to it. It's failed to connect. But if we SSH into the node and then we try to do it, we are easily able to get the hello from node app web pages content basically. This happens because this is not a public network, obviously, and this gap is filled by a service. So the external node's IP address is 192.168.1.21. The private node's private internal IP address is 10.0.2. And then the port that the application exposes is running on port 80. Now the service acts as a bridge between the internet and the pod. So any traffic that comes through this port 30,002 would be redirected through the service and then go to the pod. While if you do the same thing, if the service sends back response, it will go through this route and we will be able to access the application externally. This port doesn't matter. This is just an internal port. This port is important because this is where the application is sending and receiving data from. And this is the node port. So this type of service called node port, and we will see more about it. But it is opening a port on the node itself. So this is a node port. There are three types of common services in Kubernetes. There is a node port, there is a cluster IP, and a load balancer type of service. So this we are not going to cover, but this is present on most of the cloud providers. and it handles it load balances everything on its own. We don't have to do a lot more in there. And cluster IP services are the ones that are interconnected inside of the network. So this is um, the one that is cluster IP, and this is the one that is node port. Now let's look at in more in depth about the node port thing. So like everything in Kubernetes, services are also an object, and you can write a YAML file for it in a descriptive manner. So we have a YAML file here. The kind is service. The name of the service is Nginx service. The type of the service is node port. This is the important part here. We are the target port that we want. This is the one that is exposed by the container is port 80, and the port of the service is also port 80 here, but it can be literally anything. It doesn't matter. The node port that it is opening on the internet is 30,002. The range for these ports is, I think, from 30,000 to 32,000 something, but you can at least open 2,000 ports if you need to. And then at last, it has a selector tab. The selector comes in handy because these IP address pods go down and come up all the time. These are not permanent IP address. These change all the time. These are not static. So that's why we can use a selector to select one or any pod with the label of app nginx and group frontend. So as long as that works, we will always select the correct pod on the system. So once we do that, now if we do curl and the node IP address, then the node port, we will be able to get an hello from the node application. The cluster IP service is for intercommunication of the app from the internal network. So now let's say that there are front-end pods, there is back-end pods, and then there is a cache that is also running there. So because these are not static IP addresses, we have literally everything is the same. The service, the kind of service, we are calling it Node.js service. The type is cluster IP. This is also the default type of service that Kubernetes creates inside of the network. Now the ports are the port that the application is exposing. So 80 for the node application. This might be exposing the default port for SQL, and this might be for Redis. But this port doesn't matter. This is just the port that the service is exposed on. And then we select, like in the earlier example, we select the pod based on the labels of the pod instead of the IP address of the pod. And that's all for the basics of Kubernetes. Thanks.
Thank you so much, Sheeraz, for your time. It was very, very, very intuitive. We have many questions. First of all, a lot of people liked your presentation, loved actually your presentation. So let's go. We have the one that is always there. How do we hack Kubernetes?
So hacking Kubernetes is pretty much like hacking normal infrastructure, but because Kubernetes pods are being created and destroyed all of the time, there are other like once you have a shell on the Kubernetes cluster, there are other things that you can acquire on the Kubernetes structure cluster to gain access to more pods and the rest of the infrastructure. PwnMeow actually has created a ton of content around Kubernetes. There are few of these boxes where you can practically see how you would hack a Kubernetes cluster. One of them is Ubertonium. I don't know the name of the box is Ubertonium.
That's
um,
for anyone that wants to check out any boxes that have Kubernetes. You can just go to ipsy.rocks, and if you type Kubernetes, you can find all relatable boxes. We have also exploit path on Hack the Box. If you're playing in the retired machine section, you can go there and you can check them out. And a last question, because we're a little bit over time, 5 minutes over. What apps are good resources to learn Kubernetes?
to learn Kubernetes and Kubernetes hacking, I think one of the best resources that is free and available online that I found was Kubernetes Goat. It is really great if you want to learn about Kubernetes in the blue team perspective and at the same time in the red team perspective. You can simulate the attacks and look at the cluster how it looks, while also the opposite way. You can attack the cluster and see how the logs are generated. So I think it is an awesome resource from OS. Oh, my cat just said hi.
Oh my God, that is so cute. What is the name of the cat?
It's called Sylvester.
Ah, okay. Very. The funny thing it would be if it was called Twitter. Thank you.
Obviously.
Tweety, not Twitter, Tweety. Oh my God. Thank you very much, Sheeraz, for your time. If you want, if you can stay a little bit in the chat on YouTube, if you want to go to YouTube and answer some questions, maybe share pictures of the cat. So thank you very much.
Thank you so much, Swati, for having me. I'll go ahead and answer.